All right, guys, I am trying to screencast using a different program, Screencast-O-Matic, which actually allows me to go back and re-record things if I make mistakes. So here we go, let's try. We're going to learn a new way to multiply polynomials. Before we start, I want to remind you that yesterday you learned something like this. If I had an x times an x plus 2 x squared plus 3, then you could do the distributive property and multiply what's on the outside times each thing on the inside. You also learned if you had like a binomial, x times plus 2 times x minus 3, you could distribute twice. So this would be x times x minus 3 plus 2 times x minus 3. So that's one way to do these. We're going to learn a different way that I really think that you are going to like because it is almost foolproof. And it is the method that I prefer. Once you learn how to multiply these polynomials though, you can use whatever method you want. So the first thing that you're going to want to do is when you get some polynomials, you are multiplying this trinomial right here, okay, this trinomial, with this binomial, is you want to create a box, and that box needs to match the number of terms. So if this is a trinomial with 3 terms, we need to have 3 columns. If this is a binomial, okay, right here, with 2 terms, then you need to have 2 right here, 2 boxes here. So this is going to create a table that has 6 squares. Okay, and so one thing that helps is you can know how many squares you're going to get because take the number of terms here, you multiply them, you're going to get 6 squares. So I'm going to create this table. Okay, let's try something really quick. Let's say that I had x times x plus 7. My box would have to accommodate 1 term here, okay, and 2 terms here. Okay, how about if I had x plus 2 times x plus 7? Well, that is going to be a box with 2 columns and 2 rows. Okay, so we would put the x and the 2 here and an x and a 7 here. How about if I had an x and an x squared plus 2x minus 8? Well, that is going to be kind of a long, thin rectangle to accommodate 1 term here and 3 terms here. Okay, so let's go ahead and see the application of this and what it looks like. The next thing, as you can see from my example just above that when I was handwriting, is you take each of these terms and you write it above one of the columns. Okay, then you take your other binomial or trinomial or whatever it is, and you take each of these terms and you write it next to a row. Okay, now the move here, I want you to think about this, is whatever you want in a box is going to be a term from the top multiplied times a term from the side. Okay, let's say I wanted this box right here. This is going to be -6 times +3, or -18. So the move is something from the top times something from the side, and you multiply. Okay, let's see what that looks like when we actually plug these in. Okay, please notice that this box right here is 10x cubed, which is the same as 2x squared times 5x. That gives us 10x cubed. How about this guy? 30x was the same as 10x times 3 to give us 30x. Okay, so you're taking and you're moving these things down and across and multiplying them. Once you get them all, then you add them. It says combine like terms. We are adding like terms. Okay, these are all 6 of our boxes. All 6 of them. We brought them down. And we find our like terms. There was only one 10x cubed. There were 2 x squared terms. You can see they were brought together. Okay, 56x squared. There were 2 x terms, but they cancel. That's a 0 pair. And then 1 that is -18. So let's see how that looks when we have a little bit more of a simple model. Now this is combining yesterday's with today's. Yesterday we learned how to distribute, to multiply this monomial times a trinomial. Well, let's do the same thing using an area model. So I have a 4 here, and I have to divide this into 3. This is 3x squared and a 4x. and a minus 8. So let's do this together. Okay, 3x squared times 4 is going to be a 12x squared. 4 times a 4x is a 16x, and then a 4 times a negative 8 is a negative 32. I bring those down, 12x squared plus 16x minus 32. And here is the super cool part. Okay, this answer matches this answer. It doesn't matter which way you do it. Pick the way that you are good at. I love the table method because, like I said, it's foolproof. Let's look at the next example. We have another monomial. Okay, and we are going to take that monomial 2 and we are going to multiply it times a trinomial, 4x squared times x times 3. So that's going to give us 8x squared times 2 or plus 2x plus 6. So let's bring those down. 8x squared plus 2x plus 6. And again, that is exactly the same thing you get using what we did yesterday. Okay, which is distributive method. Let's look at one more example, quick example. This is a little bit more complicated. We have a monomial that's kind of complex here. Here's a 5r squared s squared. And here's a binomial, just a single r and a negative 3s. It's okay, you can still do this. Now remember, when you're multiplying variables, you add their powers. So this is going to be a 5r cubed s squared, and this is going to be a negative 15r squared s cubed. Now let's write our final answer. 5r cubed, that's an r, s squared, minus 15r squared s cubed. And again, that is the same thing that we got. So now what happens if we have something other than a monomial? We have a binomial times a binomial, right? Hopefully what you'll remember is that you create a box. Okay, and it has to match the number of terms. So this is an s and a 4, and this is an s and a minus 2. Let's multiply. S times s is s squared. S times negative 2 is negative 2s. Then we come over and we say s times 4 is going to be 4s. And finally, 4 times negative 2 is a negative 8. Okay, I'm going to take all of these and write them down here. S squared plus 4s minus 2s minus 8. And if I combine them, okay, you're going to find, especially when it's binomial times binomial, your two middle terms are always going to combine. S squared plus 2s minus 8. And that is your answer. Let's look at one more example. Okay, just for the sake of kind of making this a little faster, I just want you to follow. Now, this is a resource that I didn't create this resource, I'm kind of modifying. But if you'll notice, this diagram looks a tiny bit different, but basically we're still using a box, and we still plugged in a binomial on the side and a binomial on the top, and your figures are there. You can follow them. Okay, so this is going to be, let me change to my highlighter if it's going to work. This is going to be an x times an x to give us x squared. Okay, so let me erase that, and I want you to just kind of follow the pattern. This is again to get you just used to using this model. This box right here is going to be a 2 times an x to give us a 2x. And let's erase that. Okay, let's go over here. This box right here is going to be an x. Oops, I think, let me undo that. Is going to be an x times a 3 or a 3x. And let's undo. And finally, we have a 2 times a 3 to give us a 6. Okay, so you combine all of these. What you're getting is this guy right here. And when you simplify, you get this guy. Okay, let's take a look. I'm just going to have you take a look at this last slide. I'm not doing it for you, you're just watching. But I want you to notice how it was set up. This guy is lined up here and here. All right, changing the color. This guy is lined up here, here, and here. Each of these terms inside is the product of bringing something down and something over. We add them all, and then we combine like terms to get our answer. Foolproof.